Okay, so how we'll figure out the Reynolds number? We already talk about it, right? This is the formula for the Reynolds number. B is the velocity, Q by A. You can easily figure out. And this is the fluid data, that means property of the fluid, density and kinematic viscosity. Only problem dA is how will figure out 4 into cross-sectional area divided by weighted perimeter. Then you need to figure out the flow. It is a turbulent flow or it is a laminar flow. That you can figure out by right over here. If less than 2300, then it is turbulent, laminar. If it is more than 4000 Reynolds number, then it is turbulent. And in between, we call it transitional flow. Okay. Okay. Now we'll solve a problem, and it's very easy. You see, very easy, but it is related to a real world problem in pipe designing. Okay. So left side is a bigger tank, and in that tank, height of the water from the bottom is this much. And connected this tank, connected to the smaller tank right over here, his water level is remain this much. Until remain is this much, then you connect like that. Okay. So you connect, you see what is over here fitting. This fitting is called elbow because it joined to pipe in 90-degree angle. So there will be some loss. That loss will be minor loss due to this fitting. Again, you have a T over here. So here will be some losses. And right over here, you attach a bulb. If there is no bulb, water will smoothly flow from left side to right side. But due to the bulb, it don't matter. It is open or closed. The flow will be restricted. That means there will be some energy loss. So there will be loss over there, and this is the bulb. And what happened over here? From the bigger tank, if fluid is entering in a smaller pipe. So there will be some loss over here. And look in the right side, fluid is entering from the pipe to a bigger tank. So there will be some loss over here. Now, how many loss you are getting? That means minor loss. Loss over here, and right over here, all the value of KL loss is given in the problem. This one 0.05, right over here 1.06, right over here 0.02, this one 0.03, also this one 0.03. So if you like to figure out some summation of KL, if I write down sum KL will be how much? You see right over here 0.5 plus 0.03 and this 0.03. That means 2 star 0.3, right? This is one loss. Due to the bulb, there is a one loss 0.2. And other loss, certain expansion entering in the tank. So 1.06. That is the total sum of KL. This value you multiply by B square by 2G. So you'll get the minor loss. Now, how will get the total head loss? That means HLF. HLF, we know the formula that FL B square divided by 2GD, right? FL B square. Okay, B is here. So we need to figure out the If we need to know length of the pipe, we need to know friction factor. You figure out Reynolds number, then you can figure out D, diameter of the pipe, right? So we need to figure out the length of the pipe. So if you look carefully in the uh, problem, in the picture, they are giving diameter of the pipe right over here, 5 centimeter. And all the way, they don't mention the diameter. That means all the diameter is same, and it seems to same, right? If you look carefully. And other thing, you need the length of the pipe. How much will be length of the pipe? Bottom dimension, that means distance from here to here is given 80 meter. 80 meter mean 80 times 3 feet, 240 feet, a little bit far away. And what is the this height? 9 meter. So total pipe length will be this length plus this length. This is 80 meter already given, plus this vertical height. So length of the pipe will be 89 meter. Okay. Now this is just I explain you the picture. Now you look in the problem that what they are saying. It's saying water at 10 degrees Celsius temperature flows from a large reservoir to a smaller one through 5 centimeter diameter cast iron pipe. You see, before you solve chapter 9 and 8, it don't mention what kind of pipe, that it is a pipe. But right now, giving you data is the cast iron. So why given? Because we need to know the surface friction, epsilon by D. If surface friction, you don't know, but at least you know the material, then you can look to the website and figure out how much might be the average surface friction for cast iron pipe or for mild steel pipe. Okay, so right over here, this is mentioned. It's a determine the elevation Z1. This Z you need to figure out, and there is a flow rate is given 6 liter per second. Is not giving in meter cube per second. Is giving liter per second. Given surface roughness of cast iron, you see surface roughness 0.26. So without surface roughness, you cannot figure out the friction factor. If flow is turbulent, you need data. But flow is laminar, in that case you can figure out, because for laminar flow, friction factor equal to 64 by Reynolds number. Easily you can figure out. You don't need the epsilon. But for turbulent flow, you need to use the bigger equation, or you need to use the Moody chart. In Moody chart, you have this value. So you need to figure out this one. So in that case, epsilon by D, epsilon 26 millimeter, you need to convert in centimeter. Diameter is given centimeter, or this diameter need to convert in millimeter. Make sure upper and lower has the same unit. Okay. So surface roughness is given. Then what is given? Viscosity of the water is given right over here. Why viscosity is given? Because you need to figure out the Reynolds number. Reynolds number equal to mu Vd divided by rho. So you need this value. That's why it's given. Now the flow rate Q is given liter per second. From liter per second, you convert in meter cube per second. That will be your Q. This Q is divided by diameter area. That means V will be Q by A. Then you get the velocity. Okay. That velocity you put over here, you will get the Reynolds number. So let's see how we can solve it. I need to go through the MathCAD file. 1 second. Okay. Did you see the problem? Problem 2? Hello?
Yes, sir.
Okay.
Yes, sir.
So
Yes, sir.
you have diameter of the pipe. Is at first you say answer to the question number 3, then you draw the figure, then you will say what data is given. Given diameter of the pipe 5 centimeter. Flow rate Q equal to 6 liter per second. Then you convert in meter cube per second. You multiply by 1000 because what's the liter? 1 liter equal to 1000 cc. What is the cc? Centimeter cube. That is called cc. And 1 cc equal to 10 to the power minus 3 meter cube. So you can convert in Q in terms of meter cube per second. Length of the pipe given 89 millimeter. And so this is our Q, and diameter I convert in meter. And they say you need to figure out height Z1. I'll figure out. That means we need to apply Bernoulli's equation between point 1 and point 2. So if we apply Bernoulli's equation, we need a reference point. If you think this is the reference point, then this is will be Z2 4 meter already given. This is will be Z1. So obviously we need to apply the Bernoulli's equation at point 2 and at point 1. So at point 1, what is the velocity? If you maintain the constant height, this one velocity will be 0. Pressure will be atmospheric pressure. Same thing, and Z1 will be this much. At point 2, you see pressure is atmospheric pressure. Velocity will be almost 0, right? So let's figure out. So you see KL 1.5, KL 2.3, KL 3.2, KL 4 1.06. That means already given. This just say KL, but I just put KL1, KL2, KL3. Okay. Z2 is given 4. P2, P atmospheric pressure. Okay. Epsilon value is given 26 millimeter. V1 0, V2 0. P1 atmospheric pressure, also P2 atmospheric pressure. Then this viscosity is already given. I just put it over here. Rho we needed, I put over here. Now we need to use the Bernoulli's equation. So you need to use this one, alpha 1. You make sure you add alpha 1 over here, alpha 2 over here. Okay. Now you see V2 0, V1 0, P1 atmospheric pressure, P2 atmospheric pressure. So these two terms will be out. So you can Z1 equal to Z2 plus ACL. Now, how will get the ACL? This is the ACL equal to minor loss plus major loss. I will get the minor loss. Summation of KL V average square by 2G, and summation of KL, you just add all of them. So right over here. So you can calculate this term. Now, you need to figure out the frictional loss, that is called major loss. And this is the formula. FL V square by 2GD. L is given. V average, we already figure out, Q by A. But we need to figure out this friction factor F. So to figure out the friction factor F, obviously you need to check the flow is laminar or turbulent. And if you use Moody diagram, obviously you need to figure out the Reynolds number. So rho V dH by mu. You remember V equal to V average that we get from here, and we got it 3.056 meter per second. And this DH is the hydraulic diameter of the pipe. So 4 into cross-sectional area divided by weighted perimeter. The perimeter mean peripheral length. That will be 2 pi r or pi d, same thing. 4, and this is the area. After simplification, coming diameter d. Always for circular pipe, you can directly put diameter of the pipe over here without calculation, because for circular pipe, hydraulic diameter equal to diameter of the pipe. But you have to write. You say hydraulic diameter of the pipe d is equal to d, equal to this much. This is what you have to write down. You don't need to show this calculation. But if pipe is non-circular, then you need to figure out. Then you figure out the Reynolds number. We put all the value over here. This is the Reynolds number. So what happened Reynolds number? More than 40,000. So flow is turbulent, right? So flow is turbulent. Then what will be the value of this alpha? 1.05 for turbulent flow. If it's laminar flow, value will be 2, alpha 1, alpha 2. Now you see right over here, because velocity 1 and 2 becoming 0, so this whole term is going 0. So we are not worried that much. But any problem, you see velocity is not coming 0, then both point 1 and 2, you figure out the flow is laminar or flow is turbulent. From that criteria, you figure out value of alpha and alpha 1. Okay, alpha 1, alpha 2. Okay, so we got Reynolds number. Now we need to figure out the friction factor. So how we can figure out the friction factor? You figure out ratio of surface roughness divided by diameter. Make sure both are same unit. So we got 0.0052, and this is our Reynolds number. Now you need to go back to the Moody diagram. So remember this data, 0.0052 and 1.17 into 10 to the power 5, right? So if we go to the Moody diagram, I like to show you. Okay, so our Reynolds number 1.17 into 10 to the power 5, 1.17. So you see this is 1.06, 5. What is this one? 2 into 10 to the power 5, this value right over here. If you look carefully, this is 2 into 10 to the power 5. Right over here, 10 to the power 6. So our value is coming 1.17 into 10 to the power 5. So where will be our line? So that means if you like to vertical line or you like to use your scale, so let me delete this one. Right over here, right over here, 10 to the power 5, and right over here 2 into 10 to the power 5. So our line will start from kind of right over here, 1.17. Not the exactly accurate, but saying we are line over here. Okay. Now, what is our uh, epsilon by d ratio? We got 0.0052. So look, where is the 0.0052? You see 0.004, 0.006. So little bit higher than the middle, right? So we are thinking this is right over here, 0.005, just go a little bit upward, then you coming, this portion is almost straight, right? If I go straight, still there will be little bit wrong, because if you look carefully, this portion is not perfectly straight line. So you need to travel like from here is coming little bit, you need to go right over here. This is your point. So little bit at the upper level. From this point, then you come toward the left. So your value is more than 0.03 friction factor. Okay. So if we use like scale, you can get the right data. But at least you need to make sure your data is very close. Okay.
Sir, I couldn't understand the last part.
Last part on which one?
Sir, the
Body.
horizontal, yes, sir, yes, sir.
Okay.
The for the friction factor.
For the friction factor. Okay. What I was mentioning, the vertical line you understand. We are vertical line along right over here, right?
Yes,
We
sir.
make a pencil, we make a line. Then you figure out the your friction factor. We got 0.0052. Let's say 0.005. That means we are right over here, right? Yeah, right over
Yes,
here.
sir.
So right over here, if you directly go like that, you're a little bit wrong, right? Little bit wrong, because you look the graph. Say your line is right over here. Instead over here, your line is over here. Then you cannot take data from here. It will be, though difference over here not that much, but actually you will be wrong, because you have to go this way. Say from here to this line, you have to go in between. Again, I have to pick up this line. That means from here, you have to go in between. Okay. If Reynolds number coming, say right over here, say I am making a line that Reynolds number right over here, then your point will be right over here. Okay. Not this one. That means you have to go in between two lines, these two lines, because 0.005 is between 0.006 and 0.004, the midpoint. So this is 0.004 line, all the way until the over here is straight, then a little bit going upward, right?
Yes,
Similarly,
sir.
0.006, that means you have to travel between the line, then intersect with the vertical line. So if Reynolds number is right over here, then it to come right over here. Okay. Say your Reynolds number is this one. Okay. Now your friction factor right over here. Then how we'll connect the line? Then you see from here you need to go little bit in between the graph, then intersecting right over here. Then you go to the left side. Okay. You
Yes,
need to
sir.
be little bit careful. So let's go back to our problem. So I got little bit higher than 0.03, 0.015. You might get 0.012, but make sure the data is very close. If you have 0.05 or 0.06, that means is serious mistake. Okay. Now in this equation, you just put all the value right over here. So I figure out, put all the value over here. length of the pipe we know, V square we know, diameter of the pipe we know, then summation of KL, that means all the manual loss we know. So put over here, we get the value of HCl. HCl, now how we'll get the Z1? When we apply Bernoulli's equation, we got Z1 equal to Z2 plus HCl. Just put it over there. Then you get 31.675. Okay. So any question from this problem? Any question?
No, sir.
No. Okay.
No,
Based
sir.
on this problem, we will give you a assignment later on. I'll give some time. Assignment will be kind of like you are working in professional life. Okay, designing a pipeline, figure out the capacity of the pump that will give you. We apply Bernoulli's equation, then we apply the minor head loss and major head loss and figure out the capacity of the pump. Okay, this one is problem 1, problem 2. Still we have time, I think, right?
Sir, 10 minutes.
We have 10 minutes. Okay. I think we can discuss problem 2 little bit. Okay, let's see what we have in problem 2. Problem 2, it's saying a 6 centimeter diameter horizontal water pipe expand gradually to 9 centimeter diameter. Right over here 6 centimeter, over here 9 centimeter. The wall of the expansion are angle 30 degree from the horizontal. That means if you make a horizontal line, then they're intersecting right over here. Okay. So the average velocity and pressure of water before the expansion section, that means at point 1. At point 1 is given water velocity 7 meter per second. Pressure given 150 kilopascal, P1 given. Determine the head loss in the expansion section. That means you need to figure out the frictional head loss and pressure in the larger diameter pipe. Right over here, you need to figure out what will be the pressure. Absolute viscosity is given, is this much. Now you need to solve it. Now how we can solve it, this problem? Obviously, without Bernoulli's equation, you cannot do anything. So we need to apply Bernoulli's equation at point 1 and 2. So this pipe is horizontal. So if you apply Bernoulli's equation at point 1 and 2, obviously Z1, Z2 will be same. I put over here Z1, Z2 same. Velocity at point 1, 7 meter per second. At 2, at 1, pressure is given. Kilopascal, you convert in Pascal. D1 is over here, D2 over here. Then rho, this is not P, this is rho. I got mistake. Rho equal to 1000 kg meter cube because water is entering, right? Viscosity is given. So you need to figure out HL equal to how much, P equal to how much. Okay. Now you see we need to use also continuity equation to figure out the velocity because Q equal to AV. So this was just introduction of the problem. Now, if you like to figure out, you see this angle is 30. So when you figure out the minor loss, our angle will be actually total angle. So that means our angle will be 60 degree. Okay. So let's solve it. Yeah, okay. So we apply Bernoulli equation between point 1 and 2. Remember, you always apply alpha 1, alpha 2. Don't forget. If you see in the problem, data is not given, you are not able to figure out the alpha 1, alpha 2. It's a we assume alpha 1, alpha 2 equal to 1. So what will happen? I know that you know what is alpha 1, alpha 2. And if you don't put, that means I will think that you don't know anything. Okay. Now, so this is the energy at point 1. At point 2, this much energy. And over here will be two loss. One is head loss due to the certain expansion, minor head loss, and HL is the major head loss. Now you figure out the what data is given. D1 convert in meter, D2 you convert in meter, Z1 equal to Z2, P1 is given, P2 you need to figure out. Okay, then I convert in Pascal. Then rho is given. Absolute viscosity is given. V1 is given. Now P2 you need to figure out, HL you need to figure out. So V1 is given. How will you figure out the V2 and Q? You see Q equal to, we know, A1 star V1. Similarly, this equal to V2 star A2. So at section 1, V1 given 7 meter per second. Area A1 given, diameter given, right over here diameter given. So easily you can figure out V2 and also you figure out the Q if you need it. So you see, we figure out, so V2 equal to A1, V1 divided by A2, area is given, you got V2 this much. Okay. So V1, V2 we already know. Now you put the right over here, right, same equation I just put it over here, that we know that measure head loss need to use this formula, and for minor head loss we need to use this formula. We need to figure out the KL, and we know if laminar flow alpha will be 2, and for turbulent flow you will be 1.05, and measure head loss right over here. How will figure out the measure head loss over here? For measure head loss, what do you need? You need the length of the pipe. You look in the problem, length of the pipe is not given. So what you make a judgment over here? What will do? And it is a certain contraction between point 1 and 2. Okay. So in that case, you can assume sectional head loss is 0 if length is not given. Okay. And in the problem, it only say figure out the head loss in that area, but it don't say that you have to it don't say that you have to figure out the major head loss or minor head loss. Okay, 1 second. You can see the MathCAD file, right? Hello? Okay, now to figure out the value, did you see the file? I got disconnected suddenly.
Yes, sir.
Okay.
Yes, sir. Yes.
So you see, we need to figure out the alpha 1 and alpha 2. But measured head loss, we are not able to figure out because length of the pipe is not given. So we'll say this is assumed to be 0. That we put over here. The major head loss equal to 0. Right over here is 0. Okay. So, but still, you need to figure out the Reynolds number to check out whether flow is turbulent or laminar. Because if laminar, alpha will be 2. If it's turbulent, alpha will be 1.05. So we need to figure out the Reynolds number. This is the Reynolds number. Now, Reynolds number, you
Sir.
need to figure out. Yes.
Sir, B section has class from 1 p.m.
Okay, you
We need
can
to
leave. Whoever have the class will finish within 2 minutes. You see,
Thank you, sir.
this is Reynolds number for section 1, for section 2. If both coming laminar, there will be one value of alpha. But if coming one section might be turbulent, other section laminar. That's why you need to figure out the both section. So I figure out the both section and we found that both section alpha is turbulent. So alpha 1 equal to this much and alpha 2 equal to this much. So minor loss, this is the formula. Okay. Now, how will get the value of KL? You see, the angle form is 60 degree, 30 plus 30 is 60 degree. From the sheet, I already show you, you get KL equal to 0.005. So you figure out the minor loss, 0.0175. So after all data, you put it over here, then you get value of P2. That means you